Okay, this short tutorial video will walk you through some of the data collection and the techniques that you're going to be using to find the density of 3 metals. And that's what our goal is to find the density of 2 known metals. So we'll be working first with iron and then with aluminum. And then last you'll be working with an unknown metal, finding its density in an effort to try to identify the metal. So the technique that we're using is called water displacement. So you can visually see what this looks like in your textbook, but basically we're just going to start with a graduated cylinder. So we have some volume markings here on the side of the graduated cylinder. We're going to put some water in it. We'll start with 30 milliliters of water and record that. It doesn't really matter what it is, just that we record it. And you're going to add, in increments of 5 grams, your metal to the graduated cylinder. Now this is a clever way to find the volume of the metal. So when we add 5 grams to the graduated cylinder, obviously the water level is going to rise. And you're going to record the new water level. So you're actually going to record the volume in the graduated cylinder. So let's say it went up to 31.2 milliliters. When you add that first bit of metal, you're going to record 31.2. Now that doesn't mean the volume is 31.2 of the metal, because obviously there was 30 milliliters of water when you started. So you are asked in late night labs to record something called the net volume. And you're actually going to calculate it. That means what is the volume of just the metal only. So we're going to take the volume and subtract out the 30 milliliters of water, and that tells me that the volume of 5 grams of metal is 1.20 milliliters. Obviously, you're going to continue this until you've added 25 grams of metal. So upon the next addition, the water level is going to go up even higher. You're going to record that as a next volume. Let's say it goes up to 32.5 milliliters. That means, of course, 2.5 milliliters are from the metal. So record the volume as you see it in late night labs, and to find the net volume each time subtract out the original 30 milliliters that are water. Alright, so what are you going to do with this data once you have it? Density can be found by taking the mass of a sample and dividing it by its volume. So it's really how much stuff is packed into a particular amount of space. And you're going to have 5 sets of data. You're going to have the 5 gram mass and its volume, the 10 gram mass and its volume, and so on. So you'll have 5 sets of data. What we're going to do, rather than just doing this division 5 times, we're going to treat the density formula like the slope formula. So the slope of a line is the change in y and change over x, or the rise over the run. And so what we're going to do is take our sets of data and we're going to plot them. And you have directions in late night labs exactly how to construct your graph. Our y-axis is going to correspond to the mass. So this axis will be your grams, and the x-axis will correspond to volume. So your milliliters will be here. And you can label the axes, you can label the graph, and you're going to plot some points and enter these 5 sets of data, and you'll get 5 data points, and you can draw a line through them. An option in late night labs is to show the trend line, and then it will actually calculate the slope for you. And so you'll just read that, and that is, of course, going to be equivalent to the density. So you've got very specific directions for the iron example, and then you're just going to follow through with a similar procedure for the aluminum and the unknown.